Good. Using the first and last data, V average equals x minus x0 over t, which is one of the important equations in kinematics. Write it down and remember it. In this experiment, it looks as though the velocity is almost constant. Let's plot the velocity as a function of time. Subject to that constant velocity approximation, we can write V average equals V equals x minus x0 over t. So that shows us how to get from displacement to velocity. We take the slope. Velocity is the slope of the displacement graph. Going in the other direction, we can rewrite V equals x minus x0 over t and rearrange it to give x equals x0 plus vt. This shows me how to get from velocity to change in displacement. The term v times t is the area under the velocity versus time graph. I've used positive v to mean travelling in the positive x direction. In contrast, here's a negative v, travelling with the same speed but in the negative x direction. A question for you. Peter leaves home and walks east at a constant 5.0 kilometres per hour. At the moment he leaves, his friend Kate, who lives 6.0 kilometres directly east, leaves her home. She heads west, bicycling at 9.0 kilometres per hour, also constant. Note that I add the given information to my sketch. Note also that Peter's velocity is positive, but that Kate's is negative. Her speed is 9.0 kilometres per hour, but she's travelling in the negative x direction, so negative x velocity. Well, you've guessed the question. When and where do they meet? Let's do this formally, noting all the steps. Yeah, maybe you can do this one quickly in your head, but it's good to get practice in showing all the steps so that you can still do this logically when all the problems get trickier.